All right, problem number 17 asks us to estimate the point of intersection of graphs f and g and then find where they're equal to each other algebraically. I'm going to reverse this process and I'm going to start solving first. So I'm going to simply set f of x equal to g of x like I have here. I'm going to add 15 to both sides to get 5 to the x minus 2 equal to 25. Now I have really two options. I could take really multiple options. I could take a log of both sides. I could change this to both sides to base 5. I can think of this as log base 5. I've got a lot of options. So I'm going to do log base 5 of 25 equals x minus 2. Log base 5 of 25 is saying 5 to what power is 25? That entire side is 2, so 2 equals x minus 2, so x equals 4. Okay, to kind of emphasize this same idea, I could have said 5 to the x minus 2 equals 5 squared, and I'd say x minus 2 by 1-to-1 property has to be 2, so x would be 4 once again. All right, the last approach to this that I want to look at, and I apologize for any background noise, is I'm going to take a look at my calculator. I enter those. Okay, I'm going to hit zoom 6. Standard window just to see. I know x is forward where they should intersect. It looks like we're up at the top of the screen if you'll notice. So I'm going to change my y value, y max to 15 and see if that does it. Looks like they intersect. Yeah, I'd say x equal 4 is pretty reasonable. If I actually want to calculate, I can calculate by using my calculate button. I'm going to go to intersection. First curve, notice I am on the curve number 1 there, and it tells me right up in the top it's whatever I entered first, so I'm going to hit enter. Then curve number 2 is right up there in the corner. I only have 2 in there, so it's got to be those 2. It says guess, so I'm going over this region. I'm going to hit enter, and ultimately it tells me x is 4 and y is 10, so x equal 4 is a solution. That just kind of confirms it. Okay. Problem number 21, I'm not going to do the graph, I'm going to leave that up to you, but I would simply set those equal to each other. I know from my properties, ln of e to some power, since ln of is base e and we have e to some power, it's just equal to the x plus 1. They're inverses of each other, so ln of e and e to some power should undo each other and leave that exponent. So I'm simply left with x plus 1 equals 2x plus 5. Subtract x from both sides. Subtract 5 and you get x equal negative 4. And if you actually check it, 2 times negative 4 plus 5 is negative 3. ln of e to the negative 4 plus 1 would equal ln e to the negative 3. And once again, ln of e to is base e to some power. I end up with that exponent. So that confirms that that's the correct answer. You could also obviously look at those graphically as it asks you to. Okay, these exercises they ask us to solve. I could change this to log base 2/3. Rather than do log base 2/3, I'm going to do something a little different, and I'm going to take the log of both sides. So I have log of 2/3 to the x equals log of 81/16. I could have just as easily taken the natural log of both sides. Since this isn't base e, I have a tendency to just keep with base 10. I'm going to use my property now since I have a log, and I'm going to pull that x down in front, and I'd have x log of 2/3 equals log of 81/16. Now if I divide, I get x is log of 81/16 divided by log of 2/3. That'd be the exact answer. And then I'd have to fill into my calculator to get the approximate answer, and I'll do that really quickly. When I enter that in my calculator, I get x is equal to exactly -4. Okay? There's several other ways to do that. Notice this looks kind of like our change of base formula, and that would have come up if you'd actually changed that to log base 2/3. Next problem I want to look at is problem number 45, natural log. I'm going to think of that as e. Since natural log is already by itself, I'm going to say e to the 5th equals what's inside. Doesn't say do any rounding, so I'm going to add 1 to both sides. I'm going to divide by 2, and I would have this as an exact answer. And as an approximate answer on the calculator, I would get about 74.707. Okay, the last problem I'm going to look at is simplifying this expression. And really the part you need to be concerned with is this part right in here. And I'm just going to kind of stress to you this idea. If I have e to the ln of 3, I will find that if I set this equal to y, and since that's exponential form, if I change this to log form, it would look like this. ln, the exponent is ln of 3. This is basically saying that y would have to be 3. Now the idea is essentially this. I have e to the ln of something. Those are inverses of each other, and it's going to leave what's inside. So stressing that point, this part here, I have e to the ln of something. That's going to leave 5 minus the exponent of x squared plus 1. So it's going to, that e to the ln of x squared plus 1 is going to be equivalent to x squared plus 1. If I rearrange that, that would give me negative x squared plus 5 minus 1, or plus 4, or 4 minus x squared. You're done. This problem is just a solving. And my goal is to get the x by itself. So I'm going to start by isolating 2 to the 3 minus x. I'm going to add 13. I'm going to divide by 5. If I add 13, I'll get 113. I divide by 5, I'll get 113 fifths. That'll leave 2 to the 3 minus x. At this point, I can't do anything. I could change this to log base 2. That would be fine. If I did that, that'd be log base 2 of 113 fifths equals 3 minus x. Now, log base 2 of 113 fifths is, they want it at 3 decimal places. I'd have to enter log of 113 fifths in base 10 over log of 2, or ln of 113 fifths over ln of 2. And if I do that, I end up with approximately 4.498 is approximately 3 minus x. So I'm going to subtract 3 from both sides. And if I subtract 3, I'll have 1.498 is approximately negative x. So x is approximately negative 1.498. And that is it.